I'm going to demonstrate to you the PowerBender Plus I/O power supply control method. Now this is a 0 to 15 volt 50 amp power supply that also has two digital inputs, two digital outputs, three analog inputs that range between -10 and 20 volts. We also have one analog output that puts out between 0 and 5 volts. And this is the actual power supply that we're going to be using in our demonstration. And this is the control window that's controlling that power supply. And that is it's running on a Windows PC through a USB cable to control that power supply. As you can see, there are several different modes that we can run this in. Right now we're running it in the manual voltage mode, and that allows us to turn this dial on the front interface and move the voltage up and down. We can also set the current limit. It's defaulted to 50 amps, but we can set it wherever we want. Now, if you're not happy just setting the current limit, you can also set the absolute current in this manual current mode. You see you get a little slider here, and you can adjust the current wherever you want, and that is then tracked. Similarly, you can adjust the power manually. Now I guess I should turn on the current and power waveforms in our chart and maybe clean it up a little bit so you can see where they're going. Should mention that you can turn on any of these waveforms to be visible in the chart just by selecting the different enables, and you can also set the gain of them to decide where they show up in the chart. Let me show you the apply waveform mode. I'm going to get rid of the power and the current now and clear the history, so we'll just show the voltage. This is a sine wave running at 3 hertz. I'll bring that down a little bit, make it more visible in the window. So we're at about 1 hertz now, and that is set at 2 volts minimum, 8 volt max. I can also apply the waveform to the DAC and then turn on analog 1, because if you recall, the DAC was tied to analog 1 through those little wires on the front panel, and you can see that. Of course, it's clipping because it has a maximum voltage that it can put out. It's 5 volts on the DAC, whereas a power supply can put out up to 15 volts. And there's a half an ohm load on the power supply right now, so you'll notice that power is going up quite a bit, as well as the current when it reaches its peak. Okay, so I'm going to shut the analog DAC off, and I'm just going to show you some of the different waveforms we have. You're seeing the sine wave now, but we can have a triangle wave applied, or a square wave, or a sawtooth wave. The neat thing about the sawtooth is you can adjust that up over the max voltage, and I'm sorry, you can adjust the min voltage over the max voltage and invert the waveform. Okay, now my favorite waveform method of controlling this is the custom burst. I'll give you a little demonstration. I'm going to set the manual DC voltage to, let's say, around 12 volts, and then I'm going to go into the custom burst mode palette. I'm going to choose sine wave, fade out. Actually, I think all these settings look decent. And I'm going to hit the go button, and we'll see what that gives us. Some of you may recognize this waveform if you're in the automotive field. This is like a cranking waveform. So what happens is you get in your vehicle, you turn the key, your battery starts at about 12 volts. As the starter motor cranks, it pulls the battery down and it kind of oscillates back up. So it's kind of handy to be able to test automotive type applications. It's just one example, and there's probably infinite examples of things that you can do with the different selectability here with the custom burst. I'm going to go ahead and show you, I think, the digital outputs. So let me enable the digital inputs here, because if you recall, again, the digital inputs are tied to the digital outputs through those little wires in the front. You notice that when I toggle the digital outputs, the inputs also toggle both in the LEDs as well as on the waveform chart. I can also set a PWM. To hit the update button for it to go. You notice that the top waveform is on for less time than the bottom. That's because the bottom one is set to a duty cycle of 60%, whereas the top is 25%. We're running at 5 hertz right now. I think you can go anywhere up to 732 hertz, and you go down to I think 2.9 hertz. And there's varying resolution in between there. What you got to do is just select whatever frequency you want to be at. Let's see, you want to be at 50 hertz. Say update, and it gives you as close as it can get. So let's shut this off, hit update. Let me show you also the clock. So you have 4 different base clocks that you can choose within the microprocessor and the power supply. So this is a crystal based clock, and it's fairly accurate. You can divide that clock base down by up to 255, and then divide the resulting frequency again by up to 255 to give you a clock out on digital out 2. I output that clock, we don't have the resolution to be able to see that, other than we can see it's moving pretty darn quick. Okay, so if I go back to the digital out 1 and 2 here, I guess what I have to do first is update the PWM to shut those off, and then go back and see what I'm doing on digital outs. We talked a little bit about the DAC output. You can also, with the DAC, select the voltage manually here. Just dial it up and down. Now there's different ways you can adjust the voltage on any of these things that you can adjust. You can just type in a voltage. Let's say we have 1.02 volts, and there you are at about 1.02 volts, and it's reading out on the analog 1 input. And so you can see that's pretty darn accurate, and you're also seeing the waveform chart. Other ways that you can control it is you can highlight the column that you want to increase, and then you can just toggle away. Okay, I want to mention that what you see on this this waveform chart is not necessarily what you're logging as data into a data file. What you're actually logging in a data file is you log in all of these inputs shown here. You have to turn the log data button from no to yes. So now I am logging. Even if I'm not seeing it on the screen, it is logging to the log file as long as you have this turned to yes. So I've logged a little bit. Let's go ahead and turn that off. Let's just turn off the power supply. Let's take a look at our log file. So our log file comes out as a comma delimited text file, which we can then import into, say, Microsoft Excel. And you can see this is kind of what it looks like when you import it. You've got the timer in milliseconds in the far left-hand column, and then all of the other items follow along. And that is the end of our demonstration. I appreciate you guys listening and sticking around. Goodbye.